The Poisson approximation to the binomial. As mentioned, the normal approximation to the binomial holds when p is not too small. If p is tiny, for example, n times p is a constant that's much smaller than n, then the normal approximation does not work well. You can see this for yourself in simulations with codes provided. This is where we need the law of small numbers. This says that if n times p is approximately a small constant relative to n, then a binomial distribution np is well approximated by the Poisson distribution with mean mu, which is equals to n times p. Unlike the normal, which is continuous, the Poisson is a discrete distribution. It takes a single parameter mu and has probability function. Probability of p equal k is e to the minus mu, mu to the k divided by k factorial. The fact that the Poisson probability function sums up to 1 follows from the Taylor expansion of the exponential function at 0. Because the Poisson probability function is explicit, it is very easy to work with. Here is an example. Homework 2, question 2, page 134. Find Poisson approximations to the probabilities of the following events in 500 independent trials, with probability 0.02 of success on each trial. A. Probability of 1 success. B. 2 or fewer successes. And 3. More than 3 successes. We summarize this problem as follows. Let x be the number of successes out of 500 trials. Then x has the binomial distribution, n is 500, p is 0.02. Because n times p, in this case 10, which is small relative to n, we use the Poisson approximation. This gives probability of x equals 1 is approximately probability of a Poisson 10 is equal 1, which is equal to e to the minus 10 times 10. Probability of x less than or equal to 2 is approximately probability of p less than or equal to 2, and this is probability of p equal to 0 plus probability of p equals 1 plus probability p equals 2. This becomes e to the minus 10 times 1 plus 10 plus 100 over 2. And similarly, probability of x bigger than 3 is 1 minus probability of x less than or equal to 3. This is approximately 1 minus probability of p less than or equal to 3. And this is e to the minus 10 times 1 plus 10 plus 10 over 100 over 2 plus 1000 over 6. As you can see with the Poisson distribution, it's very easy to compare probability of x equals k for various different k. Doing so with a binomial would have been quite difficult.